My name is Mandy Tague, and I've been with Lanner for going on 15 years or more now, helping customers utilize predictive simulation in their world. And this is across all industries, answering all kinds of different business questions to provide that decision intelligence that they need to help them do their business better. I was listening to a song this morning by Journey was on the radio, and I was thinking about Journey, and it just kept resonating with me. And I was thinking that everybody joining the call today is really on a journey. They're on a journey to do their business better. They're on a journey to get the knowledge. We're all on a journey to get that knowledge that we need to do our business better. And today I'll be talking about the journey that we've taken to get to where we are today. My colleague Duncan Brown and I are going to be taking you through how to use predictive simulation. We'll look at some case studies and then how you can not only use predictive simulation to answer CapEx types of questions, but operational questions as well. So going back to the journey concept, let's talk about where we've been, because many of you on this call know me as being from Lanner. Lanner's been in the business for over 35 years, delivering predictive simulation modeling, consulting, training, and supporting folks that become modelers themselves with our witness simulation software. And in 2019, we were acquired by Royal Haskoning DHV, which is a very high integrity engineering and construction company out of the Netherlands. And it's been really amazing because they wanted to start a digital business line that was going to help customers deal with what the current challenges are, the climate changes, the how to make your business more resilient, sustainable, and deal with the digital transformation that we're all a part of. Everyone's on some part of that journey, whether they're just starting out and or they're making decisions about who to work with to help them with answer these questions, all the way over to starting implementation. And as Twinn, this is what we can help you do. So Royal Haskoning acquired all of these companies that had this incredible business domain knowledge and expertise. So now, as a part of Twinn, we just have so much more to offer our customers, and we're really excited about it. Royal Haskoning DHV has been in the business for over 140 years. And so we were relying on that engineering and construction knowledge that they have, and then putting our domain expertise on top of it to help our customers. So, what can you do with Twinn? Take it away. This is a great excerpt that you can get on our website to find, and it helps explain what we're trying to do and what we are doing with our customers in terms of using Twinn. So we're working to understand what are the business questions that you have and where are those risks and bottlenecks. We then want to predict forward with simulation modeling to understand if something happens, what do we do about it? How does that change and the cause and effective change impact us? And how do we then optimize? So, optimize, how do we make those improvements and how do we impact our companies and processes, be it in the facility or our service processes? How do we make impact and make those more optimal and efficient? And then ultimately, this is the goal, right? Is to prevent those things from happening because we see them coming down the pipe. We understand and know that we're going to have a high demand for our product, and so we need to understand how are we going to achieve those targets. Just look at even COVID and the supply chain disruptions. I'm sure today we can think of many different types of issues that predictive simulation modeling can solve. And so let's get into the crux of it, what we really want to focus and hone in on today, which is what is predictive simulation and how does that apply to your business? One of the key things that I'd like you to be thinking about as we look at predictive simulation is what role you're going to play. Predictive simulation is a visual representation of your world, and that can be in 2D or in 3D. You can see this model running here. Let's see, is it running? There we go. Let's get this model running. And we're going to talk about this project a little bit later. My colleague Duncan's going to be taking on the questions about or like presenting case studies and things like that and examples. So predictive simulation, again, is creating that virtual representation of your world so you can make changes in that world without having to face the consequences of doing them in the real world. So you can understand when you add a new piece of equipment or you want to introduce a new product, you want to change the drink flavor, or you're looking at a new chocolate that you'd like to create. Again, we work across all industries, so everything from nuclear waste management, food and beverage, of course, the automotive, creating engines and things like that. So many different types of business questions that we've answered, and I'd like you to be thinking about what those are for you. The reason that we use predictive simulation is because our world is very complex. All of these processes are interconnected, and there's a lot of variability going on a day-to-day basis. And simulation is the only methodology and technology that you can use and apply to truly answer these questions and understand how to optimize those. Every person on this call has a role to play within simulation. You're either wanting to get some witness software and become a modeler yourself, take some training, get some mentoring from us, or you want us to build the model for you, where you're an analyst and you're a user, where you're just inputting data and changing schedules and running the model. You don't need to know anything about witness or modeling, but you are able to interact through an interface, and or we can give you the answer itself. So we can do all of the work for you and let you know what the right decision is. So be thinking about the different roles that you could play, as well as that will help impact your short and long-term goals. This is something that I talk about with people every day, and it's a real passion and honor to get to do that. We've talked about questions that can be answered because that's what we're dealing with. There's all kinds of different issues that we're facing on a regular basis. Um, from just the process design, how are we going to make this decision? And you have a few different ideas and you don't know which is the right one to choose. So, how do we know? Again, this is what we use it for. Some of those questions include, how do you do more with less? Obviously, that's what we all want to do, and control cost. How can we optimize a new process? We've talked a little bit about that. This fits right into the continuous improvement area, of course. Uh, Obviously, it's a perfect fit and used on a day-to-day basis in many companies for their continuous improvement plans. But how do you prioritize those? How do you know which one is the best one to get the most value from? Where do you start? Where do you begin? And what is that order? We help you develop those types of roadmaps towards success when you're implementing simulation modeling. Going back to my journey thought, because it is a journey to implement simulation within your organization as well. Of course, transforming the supply chain. How do you hit those service levels? One project I was thinking about was like when the Olympics happen and we have to get all those drinks to the facilities. That's a huge spike in production as well as delivery. How are we going to meet that? Great example. Let's see, what about resources? Yes, people are asking me this on a regular basis. Someone isn't showing up, or of course, COVID is the best example of that when people weren't coming into the facilities. How do we resequence our product capability? What if we add a third shift to our, plant? How will that impact us when you're trying to get more engines out? What are the different things we can do to make sure we're doing all the right things and in the right order to make that happen? What are the risks in consolidating into a smaller footprint? This reminds me of a project where a food and beverage manufacturer that does develops chocolate that we all love, most popular products. Well, they were asking the question, is it better for us to produce all the chocolate in a large manufacturing environment, one hub that then ships out over the US? Or is it better to have smaller regional locations at different points near our customers so that, in other words, we take into account the quality and delivery time, the life of the product, that sort of thing. So we can all see how you begin to see how powerful that this is. And that's one thing that I find, once your management discovers the value, if you're not already doing this in some form or fashion, you are really going to make an impact. Again, you want to look at visibility of true capacity, increase stock. Should we be doing that or not? And again, it's evidence, because what are we trying to do? Minimize the risk of important decisions that we make. So we're taking all of this modeling that we're doing, we're coming up with answers. Let's say you have 4 or 5 people on your team, and one of the machines changed, or something about the process changed, and everybody has an idea about how they want to solve that problem. Well, how do you know what the best decision is? Of course, of course, we believe in instinct, but predictive simulation takes that out of it. It will run all the different 4 or 5 scenarios that you think will work, and then it'll tell you what the best answer is. So this is very important. And then, of course, there's the visualization. And again, it's that decision intelligence that we bring to your management so that they can then make the decisions. So when and how is it used? Let's just talk a little bit about that. We've talked about the processes and how they're complex, and we have so much variability going on a day-to-day basis. Processes have multiple interactions, and that just can't be handled in spreadsheet analysis. So many people are using Excel, for example, and they'll talk about it as being simulation or modeling, and it is to a certain degree, and that does have value. It's static, but it cannot take into account the complexities and interconnectedness and variability that simulation takes. So to me, where Excel hits the ceiling and what it can provide is where simulation begins. So I always see that as a big transition point for a lot of people that come to me saying, I just can't seem to get any further with this, and I'd like to take that next step. So we're going to be using these sorts of process characteristics in terms of data, such as product routes and flow rules, schedules, launch, equipment and labor availability. So this is just giving you an idea of some of the types of data that we'll pull into a model to give us the answers on identifying the bottlenecks, testing the new ideas, looking at the key performance indicators. And again, it provides that visual aid that you're going to need when you are reporting back to your management about what the answers are and how you can prove it to them, because you have now this evidence, this intelligence and evidence that proves your point and why you've made that decision to choose this piece of equipment versus that piece of equipment. Predictive simulation, this is one of my favorite slides. I love sharing this slide because it really hones in on the different areas in which you're going to be able to apply simulation modeling. Many people think of it as being just on the cell or the line design. So, you've got your production, assembly, packing, repair and overhaul, flow optimization. But that does feed into a facility. So we can look at facility and site logistics and resource flow, warehousing, material handling. So models can build upon each other, they can feed each other, and they can also look at these different areas of use, so you can see where it can be applied more than just on the line. In this particular supply chain, this reminds me of like a major food and beverage company looking at flour movement, because again, you can think of a raw this is in their third party network. They wanted to understand, how can we get the flour here in a more concise way that keeps the quality of the flour, because it has a life cycle on it, and it has to stay in a certain container conditions, these sorts of things. And how do we get it more optimal, faster, efficient, and with less wastage? So these are, again, I'm sure, hitting some of the things that are keeping you up at night. And that's what my goal is to lay the foundation to help you understand what simulation is, what it does, where it applies, and why you want to be using it. So somewhat recapping a little bit about what we've gone over to give you something to hold on to. If you walk away, you really want to be thinking about that simulation applies to new designs for my process, facility, or service, because we do build not only discrete event simulation models, process across time, but we also do manage fluids. So we do build fluid models for continuous, and we can you know, pull those models together if required. We have our LNG application as well that's built on our continuous models. So that's very important. Also, if you're looking at a redesign, so anything that you redesign, any process that exists that you want to make a change to, that's where this would apply. Also, for your process and planning optimization, another very key area. And again, this all goes towards the visualization and communication. Once you find those answers, because as a modeler, or if we give you the answers, we're going to be putting together a report that then feeds to your management, and we can take snapshots of the model running to help convey the answers. And again, this will become very clear as I get ready to hand this over to my colleague, Duncan Brown, again, who's going to go through some of the case studies that we have. And why are we doing all of this? Because ultimately, what we're trying to achieve is our digital transformation into the digital twin. And that is what Twinn as a whole can provide. Because a digital twin ecosystem is made up of all types of different technologies and services that bring it together. So we have the data science a capability that we need to bring in the millions and millions of data points that can feed into these digital twins and models in some cases. So we have that capacity to do that. We then are building our world in this virtual representation, and we're running the data through it. And then this is where witness and predictive simulation come in. So it's an enabling technology for that prediction of what's going to happen if I make a change. And AI and machine learning come into play. So we have a division that helps us identify how to use that. We're then and you're the analyst and or the VP, and you're looking on your phone or you're on your computer on a day-to-day basis running these optimization scenario playbooks. So when you walk in every day, you're understanding what's going on in your world, and you have triggers that can help you understand, oh, wait a minute, I see a problem. Let me dig into that and figure out, what I can do to make decisions that then go back into the physical world where the change is made and really brings all the value and impact. I would highly recommend, before I pass over to Duncan, that you look at Ben Lomax Thorpe's LinkedIn page if you get connected to him, because he's our digital twin leader, and along with Dan Van S, who does our AI and machine learning, and a whole team of folks that can help build those roadmaps for helping us get there. So these are some of the people that we work with. I'd also like to take just another second to congratulate Oliver Bird, who is a longtime colleague, and many of you may know him on this call as well, who just was announced as our CCO for our business and the Twinn digital business line. So thank you for letting me share all of that information. And I know it's going to come back to me, but let me now pass everything over to Duncan, and he's going to take it from here.
Thank you, Mandy. You made some really interesting points there. I always enjoy your enthusiasm and your smile. So thanks.
Thank you.
So my name's Duncan Brown. I'm a senior business development manager in the Twinn team. In a previous life, I have over 20 years working directly in the automotive manufacturing industry, working for global tier 1 suppliers. So I have experienced firsthand the operational challenges that manufacturers face. So in recent times, for example, the impact of COVID, the global chip crisis, rising energy costs, and the stretch on global supply chains causing fluctuations in demand. Believe me, I have the mental scars to go along with that. Okay, so just to continue what Mandy was saying, how can we at Twinn help in an operational environment? What do we actually want to achieve through the use of these tools? So what I first wanted to talk through is some of the key challenges that operational managers face on a daily basis. So number one, optimizing production schedules. I think this is one of the most significant challenges in manufacturing, is how to optimize production schedules to meet the demand whilst minimizing downtime. That really is the holy grail. By using simulation, managers can simulate different production schedules and evaluate their impact on productivity, identifying the most efficient schedule. And we can also use predictive analytics to forecast future demand, allowing managers to adjust production schedules accordingly. Secondly, reducing downtime. So unexpected machine breakdowns happen all the time, and they can cause significant manufacturing downtime, impacting production rates and reducing profitability. Simulating those breakdowns can allow operations teams to assess the impact on their ability to meet that demand. By creating a digital twin of a machine, managers can monitor performance in real time and identify potential issues before they become a major problem. So we can move into that proactive space rather than being reactive. We can also use predictive analytics to identify patterns in machine data and predict when maintenance is going to be required. Again, allowing managers to schedule maintenance and repairs before something happens, and that's the key. Improving quality control. So ensuring consistent quality in production can be a significant challenge in manufacturing. By using simulation, manufacturers can simulate different production scenarios and identify the optimal quality control procedures to ensure consistent quality. Predictive analytics can also be used to identify patterns in quality data and predict when issues are likely to occur. Again, allowing managers to make corrective action proactively, not reactively. So, Mandy spoke about it earlier. It's trying to predict what's going to happen in the future and getting some foresight of when and how that might happen and being able to make some decisions proactively. Optimizing inventory levels. So maintaining an optimal inventory level is essential to meet that demand whilst minimizing inventory costs. And I know from experience, this is something that keeps most operational people up at night. So by using predictive simulation, managers can forecast future demand and adjust inventory levels accordingly. And this can prevent things like stockouts or overstocking and reduce inventory carrying costs. Increasing energy efficiency, and I guess this is a hot topic, both in business and at home. So energy costs are a significant expense in manufacturing, and reducing energy usage can substantially impact profitability. By using simulation and digital twins, managers can identify areas of energy waste and optimize processes to reduce energy consumption. Again, predictive analytics can also be used to identify energy usage patterns and predict when energy usage is likely to be high, allowing managers to adjust production schedules accordingly. So ultimately, all of that is with a view to improving overall efficiency and profitability. Okay, so let's just take a step back for a minute and think about how traditional simulations often been used in a CapEx situation. So, classically, we identify the business questions with lots of conversations with our customers. We build the simulation model. We then run different scenarios to gain insight and ultimately make a decision. Unfortunately, this is often the end of life for that specific model, apart from updating it for future CapEx decisions or major changes. That's often where the model gets archived. Why does this happen? What are the perceived barriers to allow the model to be used in an operational use case. I mean, often there's no vision of, with our, sometimes with our customers, that simulation can be used to support continuous decision making. Frequently, the models use a manual process to feed the data, and when you're working in that operational environment, that can be sometimes too slow, and it can't provide the answers that are needed at a much quicker cadence when working in that operational field. And again, experimenting and analysing the results is not always at the user's fingertips for those people that are in that operational situation. So how can we continue to use a simulation throughout the project lifecycle from CapEx to OpEx? What we need to do is consider how we can continuously update the model and reuse the model as I've shown here. So that feedback loop. So what are the key concepts behind the move towards operational use cases? I think for me, and this is probably the most important part, is that it doesn't need any witness simulation software expertise. So models can run in the background. They can be the brain running there that you don't see. So the users do not need to be trained in simulation software. The interface can be a familiar environment such as Excel. Results can be published into Excel or Power BI. And I think for me, again, this really is the kind of key to that operational use. Secondly, it needs to be managed at a plant level by their operations teams themselves. It needs to be able to support quick and easy use of the model on a much more regular basis, so daily, weekly. Traditionally, when we're in that CapEx environment, we can run the model, and it's on a run every week or month, and it's not on that same cadence. We need to be able to, so data updates needs to be automated as much as possible. We need to be able to bring that data into the model without or with as little manual intervention as possible. And similarly, the experimentation and dashboarding also needs to be automated to allow the results to be easily accessible. And then I thought I'd put a quick thought starter here, something that kind of came to mind when we were running through the presentation, is that if we consider operational predictive simulation right from the beginning when we're making the model, then we can future-proof the model to allow it to be used in the future. So it can answer those CapEx questions, and then we can continue the life of that model to be used in an operational situation. So how can we evolve the solutions towards an operational business question? I thought I'd give you some examples of previous successes we've had at Twinn. So the first example is with Safran Aircraft Engines. So Safran had launched a major initiative to improve operational performance at their facility. So it's designed to help Safran reach its ambitions. The project focused on 5 key areas. Number 1, industrial and operational organisation, machinery and equipment, machining processes, health, safety and environment, and shop floor digitalisation. What was the solution in this case? It was one model with infinite flexibility. So we followed our proven implementation methodology to develop the model, got under the skin of the process nuances for each line, as well as the specific and varied KPIs they wanted to optimize to engineering opportunities. They wanted to look at ways of grouping machines to achieve lead time and quality targets, and ways to improve quality and or lead time by introducing automation around closed door machining. And what was the impact of all of that? It gave them the ability to do experimentation in a risk-free environment, and it was evidence-based investment. So when they were making their investment decisions, they were basing those decisions on the data provided by the simulation and by the model. And the simulation results have provided that evidence base for millions of dollars of investment, and Safran continue to use the model to inform ongoing industrial and operational decisions. So Mandy showed this earlier in the presentation. This was a project that we worked on for Hayward Tyler, who are a performance critical electric motor manufacturer. And this model was initially developed to validate a new facility. So very much that classic CapEx decision. And as the project evolved, and this is often the way with these things, that we start off with a CapEx model and then we move through an iterative process, we build on the model, and then we move it into that operational scenario, as we did here. So the project evolved. We developed a front-end user interface that allowed the client to import data directly from their ERP system and make production scheduling decisions based on future demand. We also developed an easy-to-use scenario planner, as well as a results dashboard. So all of that allowed the user to visually see the output of each scenario and very quickly get to the data without having any witness or modeling or simulation experience. What did that allow them to do? This allowed them to answer key project questions. So to get buy-in from key stakeholders, senior management within the organization. They were able to optimize production schedules, forecast supply chain performance, resolve a lot of operational challenges, and ultimately the tool turned into a bid winning tool. It allowed them to be more competitive and actually win more business. And then these are some of the key benefits of that virtual factory in this case. So their original equipment lead time reduced from 72 weeks to 22 weeks. The original equipment on-time delivery increased from 18% to 100%, which is pretty impressive. Their on-time service part delivery increased from 32% to 92%. They won some new key customers, and as a result of some of the work that we did together as a partnership, they won an award for Smart Factory of the Year. Okay, in a similar fashion to the previous project, this is an example for a very different sector, namely a financial services call center, and we just wanted to show you some more examples of how it can be used in various different scenarios. So as you can see, we developed a user-friendly interface here, which allowed data to be imported automatically. Again, it's all part of that automation of the process and not manually bringing it in. We can then run multiple simulation scenarios in the background to help our client address business questions, in this case for call centers. So it was things like workforce management, using simulation to determine optimal staffing levels, shift schedules, break timings, and those are the kind of things that you can apply to any industry. So manufacturing, non-manufacturing, really key points that could be addressed. In their case, they also wanted to look at things like call routing strategies, evaluating different call distribution algorithms, and routing rules to improve call waiting times and service levels. They wanted to look at call flow optimization. Again, this could be applied to anything with a flow. They wanted to identify bottlenecks and inefficiencies in call handling processes to streamline their operations. And they wanted to look at forecasting and capacity planning, again, which could be applied to any industry. So the simulation helps these call centers optimize performance, enhance customer satisfaction, and achieve cost savings by modeling and analyzing their operations. So Twinn customers have gained some really valuable insights into their operations. They've identified opportunities for improvement and optimized their processes to achieve their business goals. Wanted to share with you some examples of the savings that our customers have made through the use of our simulation. I think you'll agree that they're some pretty impressive results. Now I'd like to hand you back over to my colleague Mandy Tague, who will talk you through our EcoBlade solution, which brings together many of the Twinn solutions. Thank you.
Thank you, Duncan, as well. And I know we're running over time, so we'll just have we'll take a few more minutes, and thank you for staying with us. Yes. This is just to understand how simulation, we were talking a little bit about how, I'll stop this here just so we can get an idea about how you can take simulation modeling and put it across your facilities and across multiple sites. So the idea is that we have 4 different locations, and each of the location has a different responsibility. Sometimes they may make multiple products in the same facility. But again, this is creating a visualization of your entire world where it's appified and you're interacting from your phone, from your computer on a day-to-day basis. So you see the factory floor here, you already begin to see, well, the KPIs would be brought in as part of our methodology. Immediately you can begin to see color coding that all makes sense to us. So we see our our machines that are in green. Okay, things are going pretty well, so that's good. We're looking at something now here, anything pink, magenta as well, or purple. You'll see this chart here, so you'll know exactly what that means and how to dig in. Of course, we train you how to use this, and because it is your factory floor and you do know your KPIs, you're going to be very familiar. So the person that is the analyst or who's managing the full all of the facilities across the board can look at this on a day-to-day basis, hour to hour basis, and dig into the details, and then be able to call people on the shop floor to say, hey, I see something coming, something's been detected, can you go and make this change for me? And of course, it's also running optimizations when a problem does come along, so that you will then know what you need to do when you are calling the plant floor to share what the change and optimal situation needs to be based on whatever that dynamic is that's coming across, that's hitting that impact. So you've got, again, your alerts that will be helping you. We already know what your KPIs are. We have your factory floors all laid out, and everything's completely interconnected. So it's a one-stop shop. That I don't necessarily mean to use that, but that's what comes to mind right now. But it's one full comprehensive way of looking at your business, where you can again see things coming, so that you can make the changes that you need to make on a consistent basis. Since we've already seen that, I'm just sharing another type of interface and how things can look. So we're not locked into any sort of visualization of your world. It's your world, and we want to make it as easy for you to understand as possible, and taking into account all of those complexities on the back end. You don't have to worry about it. We've set it up. All you're doing is running your optimization playbook. You're coming in, you're seeing your reports here. Okay, ooh, we're down here. Okay, what's going on? Let me dig into this. And then you're able to double click on in red to find out, okay, well, what is going on? What is causing this impact that's, affecting my whip, for example? So this again is just to give you a visualization, an idea about what you can do, what good can look like in the ultimate sense. And now let's shift gears a little bit to give you a little bit of a challenge. So we have a digital brewery, and if you want to interact and try to understand how simulation can apply to a business, everybody has, a drink, if you will. It doesn't necessarily have to be a brew, but it could be anything. So it's something we all relate to. When you go, you basically get 60,000 pounds to be able to make changes across the brewery. And so what you need to do is we'll send in a follow-up email this information, and we want to see who can come up with the best answers, the best solutions for the plant. So again, you have the 60,000 pounds, and for each of the malt, milling, all of these different processes, boiling, cooling, fermentation, when you click on each of these, it will give you several questions, and then you can read through the questions and answers and make the decision to say, oh, okay, I think I'll make this option or this option. And it begins to give you that idea about how you interact with your processes to be able to make decisions. And so again, this is even looking at CO2 per drink, which is, that energy that we're talking about monitoring. And of course, revenue, which we all care about. That's what makes our worlds go round, right? Okay, so I think this is a great ending point. I'm sure many of you have questions, and we really appreciate that you've stuck with us. Again, we do have this summary slide. Let's see if I can get that to come up. But really what we want to do is just thank you for being here today. Please send in your questions. Please make time. We'd like to set up a meeting with you to talk about your particular world and what we can do to help you specifically. We've done a lot of generalities and given some great examples today, but again, what's really important is what matters to you. So thank you so much for sticking with us again today. And Duncan and I both look forward to following up with you afterwards for any questions that were sent in the chat. And then, of course, to meet with you directly about your current business concerns and requirements. Thank you so much, everybody. Have a wonderful rest of your day, and we'll be talking with you soon.
Thank you, everybody.